Let f of x be a continuous one-to-one function such that f of 2 is 3 and f of 5 is 7. And also we are given integral 2 to 5 f of x dx. This value is given to be 17. Now what is required? Integral 3 to 7 f inverse x dx is required. Right? Now if you observe this, f of 2 is 3, then for the integral the lower limit is 2 and the upper limit is 5. We know the functional values at both of them. And for the inverse function, we are having the same lower limit because f inverse of 3 is 2 itself and f inverse of 7 is 5. So this function and the inverse function are defined on the same domain. Now what we need is using this integral, definite integral value of f of x, we need to evaluate the definite integral of f inverse x. Now let us use the rules of inverse functions. The given function is y equal to f of x. Then what happens if we differentiate this? Dy becomes f dash x times dx, right? And also by definition of inverse function, we can also have y equal to f of x is the given function. Then x is equal to f inverse of y, right? That's how the inverse function is defined. Now let us evaluate the required integral. Yes, what is required integral? We need to find the integral between 3 to 7 f inverse x dx. As the definite integral is independent of the variable inside the integral, so can we also rewrite this as this is from 3 to 7 f inverse of y dy. Yes, you understood now why I converted this function, changed the variable of integration from x to y, because the definition of inverse function involves f inverse y. So we are converting into f inverse of y and dy. Now we have the value of f inverse y by the definition of inverse function, and dy value is present to us from the derivative of y equal to f of x. So let us replace both the values. This is integral as y tends to 3 by definition of inverse from the given functions as y tends to 3, x should become 2, and similarly as y equal to f of 5 equal to 7, as y tends to 7, what will be the new limits in x? The value of x should tend to 5. So here the lower limit as y tends to 3, we got x tends to 2, and the upper limit as y tends to 7, the lower limit becomes 5. F inverse y, that is x times, what is dy? Yes, it is f dash x dx. Now can we integrate this by product rule? What does this integration says? This is x into the integral of f dash x, that is f of x evaluated between 2 to 5, minus integral of 2 to 5 derivative of x, that is 1, times integral of f dash x, that is f of x dx. Now the second integral value is given to us, integral 2 to 5 f of x dx is given to be 17, and we can evaluate this. The upper limit becomes 5 times f of 5 minus 2 times f of 2, right? Minus the value of integral 2 to 5 f of x dx, which is given to be 17. So let us substitute the known values of this is 5 times, how much is f of 5? F of 5 is given to be 7 minus 2 times, what is f of 2? The value of f of 2 is 3 minus 17. Now that is 35 minus 6, 29 minus 17, which is 12. So how much is the value of integral 3 to 7 f inverse x dx? The value is 12, which is present at option C with us.